Hello everyone, I'm Shantishree and I'm excited to present our project Patient Outcome Predictor. The goal of our project is to predict ICU patient outcomes, specifically in hospital mortality and the length of stay. Coming to the paper overview, traditional models mostly use vitals alone, but in reality, diagnosis and medications also play a major role. So this work introduces a hybrid deep learning model called LSTM-GNN, which combines time series learning with patient similarity graphs. Here we are using the Cynthia dataset. This is the overall architecture of our system. The user interacts through the React-based frontend, where they can log in and view the dashboard. The frontend communicates with the backend using API calls. The backend is built using Fast API, which handles requests, processing, and sends the patient time series data to our AI model. The AI model consists of an LSTM encoder and a GNN layer that together generate patient outcome prediction. Once the prediction is made, the results are stored in the MongoDB database and can be retrieved back to the frontend for the display. The entire system is hosted and managed through cloud deployment and CI/CD pipelines to ensure smooth operation and updates. Coming to the technology stack, the frontend is built using React.js, the backend uses Fast API, and the core model is implemented in PyTorch and PyTorch Geometric. MongoDB stores patient data and prediction logs. Tools such as VS Code, Colab are used for the development and model training. And these mathematical formulas are used for the following reasons. The LSTM forget gate decides which past information should be kept and which should be removed. So it controls the memory. And in the cell state update, the model combines old memory with the new input information, and this updates the current state of understanding. Lastly, the GNN layer. Each patient, like in the GNN layer, each patient node receives information from the similar patients. This helps the model learn relationships between patients based on their diagnosis. The key results can be coming from by integrating these two learning approaches, the model showed improved prediction performance. Our implementation slightly outperformed the reference paper's results through tuning and optimization. The real-world applications can be like early warning system and resource optimization, like bed allocation, staff allocation, etc. Decision support system for the doctors and for the clinical researchers. Our model performs slightly better than the original paper, achieving higher AUROC for mortality and lower MSC for length of stay due to improved preprocessing and tuning. The model shows strong accuracy in mortality prediction and reasonable performance for length of stay. Coming to the limitations, however, the patient graph is static, computation resources were limited, and interpretability remains a challenge which can be improved in future work. And now I'm going to open up projects workspace where this is the home page. Going to the about us page. Here we have a little summary of the site and about our work. Next, here comes the contact us page where the patient or the user gives the name, email, and the message. Then this directly goes to the admin. If you're a new user, you have to create an account with the hospital, name of the hospital, the patient's ID, and the username, the email of ours, and then we put a password. Click on send OTP. The OTP directly goes to the mail. We tap that here and verify. Registration is successful. Now we log in with those credentials. Yeah, we entered into the user dashboard. It has components like profile, notifications, reports, and settings. If we want to predict, we give the patient vitals. Click on predict. We get a report which contains IHM and LOS. We can download that report. And then if we want to, we can chat with the doctor. That depends upon if the patient have doubts regarding their diet, condition or medication, etc. Here we have the downloaded reports of the patient. And then this is the overall analysis of the LOS, mortality, and the predictions. Next, here we log in with admin credentials. Admin has a separate dashboard containing pending requests and assigned cases. The job of the admin is to assign a particular doctor to a particular patient based on their hospital name and the condition of the patient. Here, admin gets notifications from the patients who wants to chat with the doctor. And then these are assigned cases. This main.py is the entry point to the Fast API backend. And this is the backend Swagger UR docs page. It is inbuilt in the Fast API. Here we can check whether the backend is working properly or not. It contains the overall uh, backend like login, email, registration, and etc. Now, this is regarding the OTP verification, where the user gets OTP and gets the message that OTP is successfully verified. This is the contact us page, where it contains all the details of the patient and their messages. And this is the prediction page backend, where the user gives all the vitals and then gets the prediction of IHM and LOS. This is the user's history where it contains all the downloaded reports and the chats with the doctor. And this is again, yeah, the chats with the doctor and the patients. It contains all the details of the doctors and all the details of the patients. And then this is about the analysis page, where it contains overall probability of IHM and LOS. And then this is about the backend for the report, downloading the report, which contains all the users' details. And for the storage, we are using MongoDB. We are using MongoDB Atlas. It is a cloud-based database system where it stores all the details of the users, like their ID, name, email, their messages, the timestamps, their reports, their assigned doctors, etc. Here, the passwords of the users are hashed. They are also not being able to seen by the admin for the privacy purposes. This hashing is used by, like, it's done by using bcrypt. And here, this file contains the connection of the overall MongoDB. So this is how our patient outcome predictor system works. It collects patient's data, processes it through a trained machine learning model, and provides a prediction that helps doctors in making faster and data-driven clinical decisions. This can be especially helpful in ICU and emergency care environments to prioritize treatment. Thank you.